Assalamu alaikum everyone, good evening and welcome to GDG Algiers. We're very excited to have you here for the second day of DevFest talks. Yesterday, كملنا day one with the very insightful talk from theory to telecom. ودوك we're back for our talk number 4. Now, إذا راكم ديجا هنا معنا, I'm sure that many of you already have an idea about today's topic. Of course, at GDG Algiers, we always, and I mean always, aim to bring you the most relevant and trending topics in tech. Today is no different because we're going to discuss one of the fastest growing fields in technology. This field is actually estimated, for those who don't know, to have a market size of over 200 billion US dollars by 2030, and it's the one and only machine learning. دوكا إذا هدرنا على talk لازم obviously نهضروا على speaker. And today we are joined by Narimane Hennouni. She is a generative AI solutions architect at NVIDIA, Generation Google Scholar and Women Tech Makers Ambassador. Narimane Hennouni, of course, welcome to GDG Algiers. It's our pleasure to have you here with us today. Without further ado, Narimane, the stage is all yours.
Much, Farah. It's an honor for me to be here and to be presenting to you. It's always a pleasure to be doing anything with the GDG. So for today's presentation, our talk today is going to be about end-to-end machine learning decisions. And the motivation behind this talk is that I want you to understand how machine learning and more specifically generative AI works. Also, need you to think of what kind of questions or decisions you have to ask yourself or make before diving deep into anything. So that's the decision-making part, like making decisions, and that's what the end-to-end machine learning decisions in the title of the talk mean. And also, I would like to give you an idea of what's available in the field, what's on trends. I'm not planning to overwhelm you, but I really hope I can give you as much of information as possible so that you can have an idea, know where to start, know what may interest you, what you're gonna look for, etc. And for questions, I will be leaving them till the end of the talk, but feel free to write them as we go so that you don't forget them. So first thing is we need to understand what generative AI means. Going to our favorite source of information, Wikipedia, generative artificial intelligence, or named as generative AI, Gen AI, or GAI, is actually artificial intelligence capable of generating text, images, videos, or other data using generative models. And it's often in response to prompts. So we will see that in detail, but what we mean by prompts is a way for us to query the model, how we're going to communicate with our model. We do that through prompts. And actually, this became more in vogue after ChatGPT was released in 2022. And now we have a big suite of GPTs, and everyone is fighting in the models arena. Also, prompts allow us to get specific information or to make specific changes or extract anything that's very specific. For instance, as you see this image of the Mona Lisa, which is, of course, not the original one. It was in the prompt that we asked the model to do such changes. And this is by DALL-E 2, by the way. How does this machine learning work altogether? Just discard the gray part about model selection for a moment. We start from data collection. So we will be collecting data, or if we have data available, we need to assess what we have. Then we're gonna process the data, do some model training, model customization, and then deploy whatever we trained customized, and then make inference with the real data on that. We will be diving into all of these models, all of these parts in details later on. And why I put the model selection in gray and before even the data collection is actually, it's really rare that we are diving into a problem or starting to work on a solution before knowing or having an idea in our minds what our model will be like. So usually, at least you will know if it's a computer vision model, if it's NLP, if it's just a regression model. So you need to have a basic idea in mind before starting the process. So that, for instance, if we are going to process your data, you know what kind of processing needs to be done. And that process data will result in specific data formats that will gonna be fed into the model and so on. So it's really important to follow a specific workflow and not do things randomly. And one thing I also want to highlight is that you need to make sure that you understand the problem, meaning that really have sit with yourself and study the problem piece by piece. Because sometimes we may think, oh, just on the top of our heads, this is gonna make things work, but it may not be the case because we haven't known specifically the details of our problem. So if you are, for instance, also with the client, it's important to have back and forth with them, communications, explanations, anything additional requirements specific to their domains, their field, etc. And also, it's really important to know your role with this workflow, because usually, especially if you're working at a company or like aside from your school projects, you would not be doing this pipeline end to end. You will be focusing on this very specific component of it. And you will be the subject matter expert of that component. Sometimes you may touch here and there, but your expertise will be specifically to one of these stages. It's all about money in the world of machine learning. It's money, money, money. It's all starts with money. Money is power. So money will give you the storage so that you can store endless amount. That's not endless amount. If you had endless money, you can store endless amount of data. You can store a lot of data. It gives you compute, which will make things faster, thus saving you time. And then time and storage, if you can store big models and you can deliver fast results and training is very fast, you will have huge performance. Huge performance, better accuracy, better models means more people wanna buy your products or use your model, meaning again, more money. And this is the flywheel of money. Another thing, what I want to highlight before we dive deep into different components is the importance of planning. What I mean by planning is that you need to have an idea in plan in mind about different decisions or the different things that your workflow gonna be composed of. The first thing, and I cannot stress this enough, is make sure that machine learning can solve it. What do we mean by that? Especially that now, like nowadays, AI is everywhere. Anyone can sell you anything just because they say it's AI powered. Doesn't mean that adding AI will make things better, easier, or solve the problem. But it may just be a waste of money, a waste of time. So you want to make sure that really ML is the appropriate solution for it. Maybe you can just do it with a mathematical function, an if-else blocks, a simple if-else blocks, or just Excel computations. The next thing is to know what is the end goal. Have a vision of what the experience will be like. What do you want your users or whoever is using the model to use it for, or how it should look like. This will allow you to plan your money budget, your time budget, and also to be realistic in terms of that. For instance, if you have limited amount of money, you cannot fancy a lot of compute. Therefore, you cannot go with models that requires a lot of training. Maybe you can, okay, let's say you can have one model that that will take a lot of months to train, but your time budget doesn't allow you to do that because you need to deliver in 1 month or 2 months, but your training takes 6 months, and that's just for the first training, without evaluating and without optimizing, etc. Also, you want to know if you want to work in the cloud or you want to do everything locally, because maybe because of security issues, confidentiality. So, for instance, if your client has sensitive data, if your data is sensitive and you don't want to host it somewhere, so that's something you want to plan for. And also, do you need GPUs or just CPUs? Mostly nowadays, like GPUs are most needed for any kind of model, even like at least a small GPU. And therefore, this will go back to your money budget, to your time budget. Do I need more GPUs to accelerate the time? But that will cost me more money. So these are things that we need to account for. We starting with the very first part. It's about data. A lot of people actually don't realize how important data is, and they will just be focusing on the models and the latest models and just trying to improve the architecture or to just further customize, fine tune, etc. But one of my favorite actually quotes or sayings like garbage in, garbage out. No matter how great of a model you have, if your data is bad, the predictions are bad, the output is bad. So it's really important to invest time and money on data. And also a lot of companies have a lot of data and they don't know what to do with it. So it's not just about collecting the data, wasting money on storage and then just keeping it like that, but it's important to know what kind of data I have, what can I do with it, extract insights from it, and then build a model on top of that or customize a model on top of that. Some questions or some things to consider when it comes to data. So the very first thing, of course, is there any data available? And if there is data, how much data is that? So that will allow me to plan for storage. Plan how much storage do I need? Can I just put the data locally? Or maybe it's hundreds of gigabytes of files. Maybe I will need a cloud storage. Also, what format is the data? Is this is it encrypted? Is it simple format? Is it just JSON structured data? Is it confidential? Yeah. So for confidentiality, for instance, you want to have some encryptions and then you have to communicate with the other part to give you keys. All of these need to be thought of so that you can build a proper pipeline. And then once, okay, you assess the data, you know what data you have, you say like, is the data that I have enough? Do I need to collect more data? If you have just 20 samples or 100 samples and you're trying to do a supervised learning complex task, that will not do the thing. Sometimes you can just augment the data. For instance, you can augment the images by blurring some of them, flipping some of them, etc. Or sometimes you just need some more time to collect more data. And then if you're doing supervised learning, we know that in supervised learning, we need the labels for the data. So that's what our model will be trained on predicting. If my data is labeled, perfect. If it's not labeled and I have gigabytes of data, how am I gonna label that? Maybe some of them is labeled, some of them is not. Small portion, maybe I can do it. Maybe I need to outsource, pay some people to do the labeling for me, and also being considered about the time budget. Another important question is where should I store this data? Data storages need to have 4 main characteristics. Scalable. Scalable means that it wouldn't be an issue for us if we do increase the amount of data that we have. For instance, now maybe I have 1 gigabyte of data, but this is not the end. I will be receiving more data. I need storage that will account for this increased amount of this increasing amount of data. Also, it needs to be available, meaning that I can access the data anytime. Reliable, if there are any issues, I can still access the data. And performant, it takes account of performance and optimization so that it doesn't cause me extra latency. It wouldn't slow my process of loading the data, processing the data, etc. And we need to keep in mind that we are storing our raw data, our processed data, and maybe even eventually our models and their parameters and whatever checkpoints and output, etc. Now, spoke about different, like we need to account for data formats and storage. There are different types of data. So we do have structured data, meaning that it comes perfectly, neatly organized, like JSON files with like metadata, descriptions, etc. We have some semi-structured data, which is like a bit, some of it is structured, but the other is still messy. And structured, there's no structure whatsoever. So it's just, for instance, let's say just files of text, paragraphs, but I need to extract it and turn it into something more structured. It can be even embeddings, like we will see later with maybe like embedding databases, vector databases. So that, like if you take your, for instance, sentence, you will transform it into an embedding, which will simplify, for instance, calculations, retrieval, etc. And the type of data will influence and impact what kind of storage options you need for that. For instance, if you are going for like, there are some versatile platforms like AWS S3, Google Cloud Storage, which is GCS, which these are cloud storage and are pretty versatile. So they can work mostly with a lot of data types, data files, and these are maybe the first go-to solution. We have also some cloud data warehouses, for instance, let's say Snowflake, Google BigQuery. This gives us like powerful and scalable querying capabilities for structured data. But if we have unstructured data or semi-structured data, we may want to go with something that offers us more flexibility, like no SQL options. Examples are MongoDB, AWS DynamoDB, etc. Now let's go into the data processing. So we have our data stored, we have our data assessed, we know how much data we have, what format, we found the perfect storage for that. We cannot just give it like that to the model. We need to transform this raw data into features. And here you will be mostly using like Jupyter Notebooks, Python, R. You'll be doing some visualizations and using what you've learned in probability and statistics. Something I discovered pretty late, I guess, but sometimes you have to restudy what you studied. But it's really important to make this kind of visualizations and make choices. Before going to the features that are gonna feed the model, we're gonna start by the pre-processing step, which affects the data as a whole. So for instance, you wanna check if there are any missing values, and how do you wanna treat them? Do you want to just impute them, meaning, for instance, taking the mean or the most recurrent value, just to replace all of those? If there are a lot of missing values, like 99% of that feature, that column has missing values, maybe you just want to discard it because it won't give you a lot of information. And then removing duplicates because you don't want to waste storage. You don't want to have the same information duplicated. And also you don't want the model seeing the same thing twice, and then it will have stronger bias toward that thing. We can do normalization so that we can make sure that the features and the values of the features will account the same, and not because just one has bigger values, it will be more important to the model. So normalization, usually like you will put something on of bigger scale or any scale between 0 and 1. And then we're gonna go to feature engineering. And feature engineering, it's basically selecting the features. And so you will end up from, let's say, 200 or 300 features. You're gonna end up with a subset of those, because you don't wanna, for instance, feed thousands of features to the model, and they are not all important. Some features may be correlated, so you want to do like correlation analysis. Sometimes you want to do like PCA, principal component analysis, so that you can decide on which features to keep. You can also just combine existing features. For instance, if a set of features are linearly related, you want to transform that into a linear formula and take 4 or 5 features, transform them into one feature. So I'm giving here just some examples to give you an idea that these kind of things exist, but it's not an extensive list, because there are like data field or model field or any field is like very deep and has a lot of things. But it's a good starting point so that one can already develop an understanding and choose or not to dive deep into these things. Usually for data processing, CPUs are enough, but it can be sometimes also very, the computations or whatever processing we're doing can be very intense and slow. In these cases, we may want to go for distributed computing frameworks. So these frameworks will allow us to process large data sets and do some parallelized computing. So maybe you will be dividing the data set into different chunks and doing the same processing on each chunk in parallel. Some examples of these frameworks you can find Apache Spark, Dask. There's also Rapid. So Rapid is like a suite of GPU accelerated data science libraries, and the good thing about them is that they match popular open source data tools. For instance, you can use the same terminology as Pandas, but you will have GPU accelerated and optimized processing. The second point I want to highlight, and which is very important, and that goes with the data processing, is the data validation. Why we do data validation? We want to make sure that when we deploy, we do not run into errors. Just because, for instance, of data types, let's say I have a column that is, let's say, binary, it's 1 or 0. A column, I mean feature, that is 1 or 0. And then when I'm getting real data, I will get a 1, but it will be formatted as string. It's still a 1, but some libraries may not like really do the casting of, like, for instance, from string to binary or to float or integers. But you want to make sure, you want to do some tests that this feature is of type binary. If it's not, then raise an error, make the user know, or whoever is monitoring the platform. And one other thing is to check for input and output formats. So if your model will be having like specific input types, specific output types, so we want to make sure of that. It's like doing, how we call them, the modular tests of, like, for instance, different functions, making sure that that component on its own work. Speaking of components, so this data processing is part of bigger workflow. So we need to make sure that on its own, it's working before connecting it to other components. Otherwise, we're just gonna be having an avalanche of errors going till the end, and it will be harder to debug. So it's really important to make sure that every component is working standalone on its own. And now, before moving into models, which is what I'm going to talk about next, I want to speak briefly about the difference between CPUs and GPUs. So I've been talking a lot about CPU, GPU optimized. So what are these? CPUs, which stand for central processing units, are the core processing unit in any computer. So we do them like, they have generally fewer amount of cores. They do general tasks. They do things in a sequential manner, and they are less expensive. I wouldn't say cheap, but less expensive, making them cost efficient. But they can be slow, especially for machine learning, because machine learning is basically a bunch of matrix multiplications. That's why we go for GPUs, which is graphics processing units. These graphics processing units will do some parallel computing so that we break down the whatever massive complex problems, computations we have into multiple smaller simultaneous calculations. They are costly. That's why I said money is power. But they are more effective. So there is a trade-off here. If you want more speed, better results in shorter time, you can afford maybe to pay this one a little bit more. And also some of them actually are even can be optimized to, like, for specific tasks. For instance, optimized for LLM, they have transformer engines and stuff like that. When it comes to models, we can have plenty of models, plenty of model choices, and it can be overwhelming. So which models should you go for? Nowadays, with the development in AI, it's really rare that you will build a model from scratch, unless, for instance, you do it some research, like trying a new architecture, or maybe doing something very private and you want to have in-house proprietary, etc. Usually, we use pre-existing models. The type of the model that you choose, depends on the type of the task and its complexity. Do you want to do supervised learning? Do you want to do computer vision? Do you want to do something that is NLP based, like understanding, summarizing, and even conversation, like chatbots? Also, you need to account for available resources and budgets. You don't want to, like, go for big model a model that's super powerful, kind of GPT or Llama, and you have just CPUs, or you have few gigabytes of whatever compute memory. That's not gonna fit. It's not gonna work. So you really need to account for whatever resources and budgets that you have, time, money, time, and storage. And also, you need to account for any additional requirements your client may have. So, for instance, your client doesn't want to have confidential data, and they just don't want to use anything that makes API calls. So, for instance, if you're considering using ChatGPT API, they don't want you to send your model, their data to the API. For instance, they just don't like that company. They don't want to work with their product, anything like that. But the bottom line is that don't go fancy. Just choose the simplest one that does the job. Avoid overcomplicating as much as possible, because that's going to cause you more headaches, more issues, and not solve your problem. Now, I said, like, usually we don't go from scratch. And one very good available option for us to use models that are already pre-trained as are open source models. So what are open source models? These are just like open source models or projects that are publicly available under certain licenses, and under certain licenses, they allow you to make changes, to use them, to customize them however you want. Why it is good, or maybe better in certain scenarios, to use these open source models? It saves you time and guarantees better performance. How is that? So it saves you time and guarantees the performance because people already spend a lot of time to get the best performances. So you're not doing all of that, like training, and you may do some more customization, like fine tuning or something, but it's not as long and heavy as training. You want to be looking for the best hyperparameters for the overall model and for all the weights that your model has. It's also cost effective because it's available for free, so you can use it. It allows for customizability, meaning that you can fine tune them and adapt them to whatever specific needs that you have. It also has big community support because these models were developed by, can be most of the time like experts or sometimes big companies. There you will be using the expertise of a whole global community. In case you have issues, you can ask questions, and people are really happy to help and are nice. And also transparency and trust, which is very important because you have access to the model's architecture, you know what training data it was trained on, therefore it will allow you to understand and trust the model output. Just one thing I wanted to highlight is that if you are building, for instance, your model on your own data, like especially like proprietary data, it's kind of sensitive. It's best practice to not open source it because it can be reverse engineered, and reverse engineering will cause leaks of your data. I've spoke a lot about model customization. So what does it mean? Model customization is basically taking whatever pre-trained model that exists. There are a lot of models, and customizing them, making them more specialized to our needs, to our use cases or domains. Whatever I'm be talking about next will be maybe, sorry, whatever be talking about next will be a bit more focused on LLMs, since it's the hype right now. That's what people are mostly working on and using. And we have actually different techniques to do this customization. Some of them concern the prompt phase, which is just us interacting with the model and asking the different questions, how we're gonna prompt it. So that will allow us to customize the output of the model. We can do some fine tuning, which means that we're gonna mess a bit with the model weight, or we can do even retrieval augmented generation, short for RAG, that will allow us to add some external database that, combined with our prompts, will direct the model to our desired output, which is more domain specific and more tailored to our use case. Starting with prompt engineering. what is a prompt? So prompt is the user-provided input to which the model is meant to respond. For instance, you can see here in the image that we given this model the prompt of like having a cat in a lab, and DALL-E 2 will be generating this image. So the output of the model is based on our prompt, on what we are asking for. Prompt engineering means that we're gonna carefully take time, be specific in your prompt so that you can generate specific output. Instead of just asking for something in general and thus receiving general question, you're gonna try and guide the model towards your desired question. And we have different strategies in these. We have zero shot prompting, few shots, or even chain of thought. So zero shot means that you are prompting the model without any examples. For instance, if you ask it what's the capital of France at first, it will tell you France, which is wrong. I guess we all know that it's Paris. But if I'm going to give it a few examples, for instance, I will give it all the block that you see before the answer. I will give it the question, what's the capital of Spain? And I will give it the answer, say in Madrid. And then I will ask it, what's the capital of Italy? And I will give it the answer, it's Rome. Then I'm gonna ask it, what's the capital of France? And it will hopefully answer Paris. So this is few shot prompting. And then we also have something else called chain of thoughts. For instance, if I don't know, like a lot of people may have noticed that these models are really bad at maths, and most of them are trying to use like if you're developing it into an application, you're gonna use some plugins so that if there's a math question, then it's gonna, for instance, make a call to a calculator API or any other API that's gonna be doing whatever reasoning. So one way we can work on that little on prompts, which may not guarantee the best accuracy, is what we call a chain of thoughts. So in that prompt, you're gonna tell the model how to think. You're gonna push it to reason. So for instance, you're gonna tell it that usually if you wanna do 2 plus 2, you're gonna take 2 and then add it to what, this is a bad example, but I'm just trying to tell you how to make the model reason. The shortcomings of this prompt engineering is that usually we will be appending this logic in our prompt, which is gonna affect the token window that we have. As you know, for instance, large language models have a specific number of tokens, like which we call like a context window that you can feed into them. And if you're gonna be putting a lot of that, it risks going over the window, so you cannot. So you're gonna be hitting the limits, and for every token, you're gonna be paying for that. So it's gonna cost you more money. The second customization technique is fine-tuning. So fine-tuning is the process of adapting a pre-trained model for specific tasks or use cases, but this time it's not using the prompts, it's not touching to the prompts, but rather you will be touching the weights. So you have a model that's trained on large amounts of data. You're gonna take it, you have your own data, specific data. It's usually smaller than the amount of data that the model was trained on. And then you're gonna fine tune it, like do some more training or add more things that will make the model more customized to your thing. Usually there is kind of not a fear, but I would say something called catastrophic forgetting, which means that sometimes if you do train your model a lot on your own data, it risks forgetting what it learned from before. So this is why we have different techniques depending on what's your end goal, how much you can afford. Going from left to right, we will be having increasing accuracy, but also increasing investment in money and compute. So we have, for instance, prompt engineering, which is something that we've talked about. So you will be basically just feature engineering, sorry, not feature engineering. You'll be prompt engineering the prompt, making different changes. Then you have prompt learning. I'm not going to go into the details, just letting you know what's there. Be happy to discuss it further later. So prompt learning, for instance, there's something that we call p-tuning, which means we're gonna be adding some tokens or values to our embedding vector so that the model can learn more specific things as we go. We have PEFT, which is parameter efficient fine-tuning. Why we call it parameter efficient is because you're not taking all the weights of the model, but taking a selection of those weights and further training them on whatever data you have. And then we have like very heavy focused fine-tuning like SFT, which is supervised fine-tuning, or LHF, reinforcement learning from human feedback. So for the SFT, it's like you're gonna take the model and train it on some labeled data. It will be a subset of data. It's not like a large amount of data that is labeled. To label it will be your desired output, and then you're gonna fine-tune the model on how to respond to specific inputs that they match the label. The third customization technique is retrieval augmented generation, which is known in short as RAG, which is a technique that improves large language models output by consulting a knowledge base. So we will not be doing any further training. In fact, you can combine like fine tuning and RAGs, but let's start simple. It's just by doing RAGs. So you will have your own data, your own documents, and you have to do data processing, you have to clean it, and then turn it into embeddings, store it in a vector database. Why we call it a vector database? Because it just has a bunch of multidimensional vectors, which are which is your data transformed into embeddings. Why we use also embeddings? Because it's more efficient, so that when we're doing the retrieval, it's just gonna be dot product between the embeddings. We're gonna take the user query and try to match it with the embeddings that we have in our vector database. Have the top K results. K is a parameter that can be optimized. We're gonna take whatever the results we have, add it to our original prompt, and give it to the LLM. It's like you're giving the model kind of the possibility to cheat by giving it a bunch of information that will help it get the correct answer that you're looking for in that specific domain. And then you get your response. Vector databases are the core of this RAG system. They are really important because they will be storing the information that without it we cannot be doing any retrieval or augmenting our models. We have different tools that will allow us to connect these LLMs to the vector databases. I want to highlight two most commonly used ones are LangChain and Llama Index. They also provide other features like evaluation, because of course you want to evaluate your RAG pipeline after creating it. Doesn't mean that it's going to be working straightforward. You can have different querying methods, etc. And then we have our model evaluation. When we have a model pipeline or a RAG pipeline, whatever pipeline, we want to evaluate it. We don't want to just use it like that. So by evaluation, we will be assessing how our model is performing on a specific evaluation setup. It's like when you split your train validation test splits, that evaluation is going to be on the final test data set that you have. We will be computing some metrics that will guide us into knowing like, is our model doing good or bad. After that, we're going to proceed to our model selection. Model selections means, for instance, if you have some hyperparameters in your model, you want to do hyperparameter optimization, which is the process of finding the best set of hyperparameters that improve the model's performance. So when you're doing this hyperparameter optimization, you will be having different versions of the model, each of them having their own set of hyperparameters. And then you're gonna compare them based on the metrics that you've chosen depending on your task, and choose the best one that you think is the best. There are different metrics. So we have, for instance, if we're talking in general, we have RMSE for regression tasks. We can use F1 scores, for instance, for classification. And we also have some specific metrics for LLMs. Some of them, like we can classify them into 3 categories. General metrics that you usually use in natural language processes, like the blue or orange scores. We also can compare them to how they are doing compared to other benchmarks like glue or truthful QA. And also there's a new technique that's being used is like using AI to evaluate AI, basically called as LLM as a judge. So we'll be having another LLM that's specifically trained to evaluate how your LLM is doing. Yeah, mind-blowing can be, but everything needs to also be at certain times evaluated by humans as well. As much as we have a lot of faith in AI, it's very important to have some human supervision, which also leads us to responsible AI. In responsible AI, there are different techniques on how we can assess the fairness, if there is no bias in our data, in our models' predictions. I want to highlight 2 points here. There are a lot of different methods. So one of them is called RLHF, which we already mentioned in fine-tuning. And it is part of fine-tuning because what reinforcement learning with human feedback will do is that will enable the model to adapt its behavior back on the feedback it received. This feedback is usually to align it with human values and preferences. So it's kind of fine-tuning because you're also customizing the model, but it's part also of responsible AI because you want to align it with human values, make sure it doesn't say something wrong, bad, depending on the community, depending on a lot of things. You can find a lot of details on this online. Just giving like high-level overviews there. And for instance, if you are using APIs like Gemini, Palm, even GPTs, they usually have some parameters that you can set in order to adjust the safety settings. It can go from low to high on a scale. For instance, like there are 5 different values, and they have different categories. So it can be like harm category, it can be harassment, it can be racism, etc. So these are things that you can set in your GPT. Are my slides still showing? Okay, thank you. Yeah, and then of course the last phase that we have is deployment. Actually, sometimes there are 2 things that get confused, which are deployment and serving. So by deployment, we mean making the model ready to handle real data, and that will start delivering insights. So we're just gonna be integrating it into our production environment. And the second thing is serving, where we will be actually getting the model to start operating. We start feeding it real data, process like real incoming data, and provide predictions. It's really important to consider a few things when doing deployment. One thing is evaluating the traffic, because sometimes high traffic scenarios, like there are a lot of traffic. Traffic, we mean how much data we're getting. High traffic scenarios where maybe need a robust infrastructure with a lot of computational resources like GPUs. Or sometimes there are like some low traffic seasons or like off-peak seasons when we need just CPUs and you don't want to waste money on GPUs that are not being used. It's also very important to always keep an eye on the data, the models, and the serving. Just because, for instance, you did deploy it or you did serve it, doesn't mean that you're done and everything is working perfectly. You always need to see if there is nothing going wrong, if things are working properly, if the results are what we expected, which takes us also to A/B testing. So for A/B testing is what usually we do is that before fully deploying the model, making it into production, we'll be testing the model on another subset of real data. I know we did the testing before, we did the validation, we did the testing, and our model is ready to be deployed, but we still need to have it run on real data. Maybe the real data that's coming has a different distribution that what was trained on, thus leading to results that are of lower accuracy. So these are things that we really need to keep in mind. And also we have some considerations to take. for instance, how do you want your models to be, how do you want your model to process the data, the incoming data? So we have batch processing, streaming processing, and real time. Starting just with real time is that it's hardly ever the case. I like this quote, like everyone wants real time, only very few know why, but no one is willing to pay for it because it's super expensive and intensive. Batch processing is that you have your, you're not going to do each sample at a time, give it to the model, have its prediction. You're gonna just take a bunch of data, pass it through the model, same way almost as you do with like training your model, having batches of data, and you have a batch output. You can save it and then query it whenever you need something, or you can just then put it out one by one. So this can be like, for instance, if you're just like doing some analytics, or there isn't really need for something instantly available. And then we have almost real-time processing, which is streaming processing. Streaming, we mean by streaming, it's like you're gonna have continuous, never-ending data. Wherever data comes, you pass it to a model, have the output. It's always active. It's always on the clock, and that will give you like instant results that are available whenever the user needs them. We have a bunch of different tools. Actually, there was also the talk yesterday from Akram Boutushant, was really good about Kubernetes. Kubernetes is really known for like the deployment. It's really helpful. There are other platforms like, for instance, Vertex AI. We can use Docker containers, etc. But the main thing to consider when you are using this, when choosing these deployment tools, is first compatibility. What do we mean by that? Is that you want to make sure that this platform supports different kinds of models, frameworks like TensorFlow, PyTorch, etc. You want it to give you the possibility to be flexible and customize your model. You want it to be performant and scalable so that it makes good use of your compute resources, that you can increase the data, you can have even bigger models, or maybe like fine tune. If you have fine tuning and you have a new set of weights, you want to make sure that you keep those, and also allows for collaboration between your team members. And then the last thing I want to highlight here is the security aspect. So we want to make sure that whatever we're doing is not, especially if you are in very sensitive, working in a sensitive, on a sensitive case, or with a company that has like sensitive data, you want to make sure that you apply encryption techniques like SSL, TLS, so that the transit of the data is, and communications within your machine learning infrastructure is safeguarded. You want to also implement some access controls, authentication mechanisms, so that you have restricted access to your sensitive resources and APIs. You want to always regularly, more or less, update and patch wherever components you have, like software components, databases, APIs, so that you address any security vulnerabilities. And also, you may consider deploying your models within secure and isolated environments like Kubernetes namespaces, or virtual private clouds, so that you ensure like compliance with data protection regulations. And that's it. I know this has been maybe a lot of information that can be really overwhelming, but as I mentioned before, it's really important to know what's there. That's what I'm trying to give you here, and give you at least sort of starting point. But most importantly, make sure you have fun while you're doing anything. So have fun learning, have fun building, have fun having to deal with a lot of storage issues, compute issues, lower accuracies, but it's gonna get better. So I'll be taking also any other questions, any questions that you may have. Thank you so much for listening.
Thank you so much, Nariman. That was very, very interesting. As you said, the most important thing is to have fun. Of course, there are a couple questions here. If you're ready, I will tell you the first question. So
Sure.
the first one we had is how to monitor and keep track of the model's performance after the deployment.
After deployment. So this actually takes us back to So when you have like these tools, it's there where you can always supervise whatever whatever it's going on. You can see if there are any issues in traffic, if the data is going well. It also gives you like that's why we usually go for these tools, and you are not going to do it like step by step yourself, because it will give you charts on different predictions, the different, like for instance, if you are serving it as an API, how many calls there were, if there were any issues. So these tools will be your number one guidance onto how you will be evaluating and assessing your model after deployment. And then you can take, after that, necessary actions. Maybe you just need to make radical changes, remove your model deployment, redo changes, and then redeploy it again.
Perfect, Narimane. Thank you very much. One last question. Someone said, which one is better to use, RAG, RAG, or fine-tuning?
Actually, it's not a question of what's better than what. And as I mentioned, you can use them actually both together. So these are two different things. Think of RAG as if you're taking an exam and you have your open book, so you can just get immediate access to the information whenever you need it. But then fine-tuning is like you spent a lot of time learning, and you just gonna, like at the time of the exam, you gonna give the result of whatever you learn. So in RAG, you're not touching the model weights. So if you want something just an extra and not touch the model weights, not add an extra layer of weights that can be added, for instance, with let's say here you have parameter efficient fine tuning, and you can have some LoRa adapters on top and all. So you won't be needing those. But also the data, sometimes it doesn't have everything, your like specific data, and the process is kind of costly and intensive because there's a lot of things that needs to be going on before you start making predictions. But if you are fine-tuning, you will just do it once, fine-tune it, and use it whenever needed. And so you will spend more time in fine-tuning, less time in getting your responses. But for the RAG, you will be having it each time. You will be doing the process each time there is a prompt or a question. So it's not really which one is better than one. It depends on your use cases, whatever data you have, what are your goals. Always like think of your end goal. What do you want? How much you can afford? And they can also be all combined together. Like you can do fine tuning and then enhance it or augment it with RAGs as well.
Perfect. Thank you very much. One last question before we conclude very quickly. Someone said, are hypothesis testing methods really used in industry situations? If yes, how?
Yeah, of course, that's a good question. But to be honest with you, I also, me myself, wasn't very focused when like at school or something in probability and statistics. Not, I wouldn't say like really focused, but I didn't know what was the real use cases of them. But then when you start interacting with the data, you really need these things. So for instance, for as you mentioned, the hypothesis testing, you want to make sure if you're getting any signal of or if this kind of feature important to the model, you can do, there are a lot of ways to do things, but one of them is definitely is definitely hypothesis testing. As I mentioned before, we can do like sometimes like correlation. We can just change the feature and see if it impacts the model. But our like the current libraries like pandas and wherever other data science libraries do have the option to do this hypothesis testing.
Perfect. I think that was very clear. I think we should conclude with the questions. As always, thank you, Nariman,
Yeah,
very
and of
much for
course,
this.
feel free to connect with me and ask me any other questions that you may have. I know we're a bit tight on time here. Okay, let me give you my name again. Sorry. You connect me on LinkedIn, or maybe even GDG can share my slides or my email. Oh, I don't have my name. Sorry. Yeah.
We shared your name, we shared
Okay.
everything on our social media, so don't
Good.
worry. As I said, thank you very much. It was such a pleasure having you with us today. Thank
Pleasure
you
is
everyone
mine.
for joining us. بلا كترة طيب by the way. طولت الجاي إن شاء الله هالتونيا led by the Google Developers Expert from GDG Algiers, عز الدين شنين. He's going to talk about AI agents. Again, thank you everyone, and see you in the next talk.
Thank you.